Back 6.2 problem 3. About 25% of those called for jury duty will find an excuse to avoid it. What does that mean? Probability of success is 0.25. Alright, so let's write this down. Probability of success is 25 percentage, that is 25 over 100, that is 0.25. But what is success in this case? Success is you find an excuse to avoid jury duty. Okay, let's keep that in mind. 10 are called for jury duty. So n equals 10. What is the probability that all 10 will serve? All 10 will serve means nobody succeeded. Success is to avoid jury duty. If everyone is serving, this means we have zero failure. So in a Bernoulli experiment, n is 10, probability of success is 0.25. All right, I hope you can see 0.25, and you want zero success. So we are looking at 0.056. All right, 0.056. What is the probability that 3 or more will not serve? That means you have 3 or more successes. So you want to add all of these numbers, this plus this plus this plus plus so on. So starting from 3. So you could either add all these numbers, or you could say 3 or more successes means from 100% take away 0 success, take away 1 success, and take away 2 successes. Okay, 3 or more is opposite of less than 3. So you take away the successes less than 3. Okay, probabilities of fewer than 3 successes you take away from 100%. 100% is simply 1. So from 1 take away these 3 numbers. That should give you probability of 3 or more successes. All right. Next. If x is a binomial random variable, compute probability for each of the following cases. X is 2. All right. So you want 2 success when n is 5 and little probability is 0.5. So n is 5. So I'm looking at these block of numbers, but probability of success is 0.5. So I better look for 0.5. That's 0.5. So I need that column. Okay. When n is 5, now number of successes is 2. So that fetches me 0.312. 0.312. N is 5, x is 5, p is 0.1. So I'm looking at p is 0.1, that guy. Okay, that column. N is 5. That's the block of numbers. X is 5. So you want 5 successes. 5 successes happens 0 probability. N is 4. Okay. N is 4. X is 0. P is 0 0.8. 0 0.8 is over here. N is 4. Number of successes 0. And 0 0.8 is the success probability of success. 0 0.002. Lastly, N is 4, X is 3, P is 0 0.7. There is 0 0.7. N is 4, X is 3, 0.412. 0.412. Next problem. Probability X less equals 1. N is 7. This block of numbers. P is 0 0.8. That's 0 0.8. So when N is 7, I want less equals 1. So I could be 0 or 1. Less equals 1. So I need to add these two numbers. 0 plus 0. N is 9. P is 0 0.5. 9 is here. P is 0 0.5. That's here. Zero 0.5 for P. N is 9. And I want to be X greater than 8. Greater than 8 is only 9 as an option. So that gets me 0 0.002. Okay. N is 8 and P is 0 0.7. N is 8 and P is 0 0.7. There you go. 0 0.7, those are the numbers. N is 8. We want X less than 3. So less than 3 means 2, 1, 0. So these three options, 0, 0 plus 0 0.01, 001 plus 0 0.010. Now lastly, X greater equals 3 when N is 4 and P is 0 0.3. So N is 4 and P is 0 0.3. All right. And you want to be greater equals 3. Greater equals 3 means 3 or 4. These are the only two options when N is 4. 3 or 4. So my numbers are these two. So you get 0 0.076 plus 0 0.008. All is correct. That's the last problem. Next videos will cover section 6.3. Until then, bye.